Hey guys, Algebra 2 Part 2. We are going to work on positive and negative radicals today. So the first thing that we're going to look at is we are going to look at negative numbers that have been raised to a power. So normally in school, I would have you go through this, write this all down yourself. But obviously we don't get to be in school, so we are going to be working on it just together. So I've written all the answers. So negative 2 squared, that means negative 2 times negative 2 is 4. A negative times a negative is a positive number. Negative 2 cubed, negative 2 times negative 2 times negative 2 is a negative 8. Negative 2 to the 4th is a positive 16. Negative 2 to the 5th is a negative 32. Negative 2 to the 6th is a positive 64. And negative 2 to the 7th is a negative 128. So what I want you to realize is that each of these powers, 2, 4, and 6, those are even powers. And notice, when it's raised to an even power, it is a positive number because I have a negative times a negative. Even numbers of negatives. So it's going to be even. Where here, 3, 5, and 7, odd powers, we end up with a negative number. Now, that's going to be important when we start taking the square root of something. For example, if I tried to take the square root of something, remember, when we try to take the square root of something, it becomes an imaginary number if it's negative. So the square root of negative 4 ends up being 2i. It ends up being imaginary. That's important because notice, a negative number times itself is a positive number. It doesn't end up. So we just went over where we took a negative 2 and we put it to a certain power. Now we're going to look at if we're taking a root, a square root, a cube root, a fourth root of a negative number and what that's going to look like. So the top part of your notes, if you filled that in, is going to be the powers, and then this is the bottom part of your notes so far. So if we take the square root of a negative number, it becomes imaginary because remember, the square root of a number is a number times itself. Well, we just saw that a negative times a negative is a positive number. So we can't have two negative numbers that would make a negative and two positive numbers multiplied by themselves don't make a negative. So we have to have an imaginary number, something that takes the place of the square root of negative 1. Now, remember, when we took negative 2 cubed, it became a negative number. Just like that, the cube root of negative 8 is going to be a negative number. So if we look here, remember, if you don't see a number there, that's considered a 2. If we look at these indexes, I have 2, 4, and 6. Those are even numbers. They're even indexes. And look, our answer is all imaginary. Where, if you see here, 3, 5, and 7, those indexes are odd, and our answer is all negative. So one of the things that I have on the bottom of your notes, in bold, starred, massive thing that I want you to recognize is that if our index is even, and it's trying to take a negative number, we're going to end up with an imaginary answer. If our index is odd, and we have a negative number, we're going to end up with a negative answer. So the first problem we're going to work on is the square root of negative 98x cubed. Remember, when I don't see an index number there, it's a 2. So we have to break this down. We have to break down our 98 and we have to break down the x cubed. So we're going to break down the 98. 98 is an even number, which means that I know that it can be divided by 2. So it's, what is that, 49. And then I know that 49 is a perfect square, 7 times 7. If you don't remember that, look at your factor sheet. I think that I've uploaded that to the website. And then also remember that x cubed means that I have 3 x's. Now, all we have to do is circle things that are 2. If we've got 2 of something, we break it out of jail. So I've got 2 7s, 2 x's. So it's going to be 7x. Now the other thing that I have to look at is this is a negative number. And this right here is an even index. Remember, whenever we have an even index, it becomes imaginary. So I put my I there, and then I put everything else that I did not circle inside my square root. So I have a 2 and an x that I didn't circle. So the way we break this down is just like everything else we have been doing. We're going to break this down into its prime factorization, numbers that are prime numbers. We're also going to write down any number of our variables. We're going to circle the number that is in our index. Whatever we circled comes out. Whatever we didn't circle stays in the square root. Then we have to look and see, because this is a negative, is our index even or odd? If it's even, it becomes imaginary. So problem 2 is the cube root of negative 875 x to the 5th. So what we're going to do is we're going to break this down. I see that it ends in 5, which means that I'm going to want to divide by 5. When I do that, I end up with 175. So 5 times 175 is 875. And then I can break that down further. Again, it ends in 5, so I'm going to divide by 5. 5 and 35. It ends in 5 again, so 5 and 7. And then the next thing I'm going to do is I need to break down my x to the 5th. So I'm just writing 5 x's. So we're almost done. Let's do pink. Where? Notice my index is 3. That means I need 3 of a group to break it out of jail. So I'm going to circle groups of 3. That's all I see, that I have groups of 3. So I have 5x. Now, the other thing that I have is I have this negative. So I have to look and see, is my index even or odd? 2, 4, 6, 8, that's even. 3 is not even, it's odd, which means this becomes a negative. Whenever my index is odd, then I have a negative. I'm going to write whatever I have left inside my root. I have a 7 left over, and I have 2 x's, or x squared. So to break this down, we're doing the same exact thing that you did last week. The only difference is we're looking at our index. If it's odd, then my answer is going to be negative if I have a negative inside there. If it's even, I'm going to end up with an imaginary number. Let's look at number 4. So number 4 is the 4th root of negative 392 x to the 6th. Again, we're going to break this down into prime factorizations, or numbers that are prime numbers. So 392, I see that it is an even number. So 2 and 196, and then 2 and 98, 2, 49, 7, and 7. And then I have 6 x's. 1, 2, 3, 4, 5, 6. We're almost done. I'm going to look at my index. My index is 4. That means I need 4 of the same exact thing to break it out of jail. So I'm going to circle 4 2's. I think I must have missed a 2 somewhere, guys. I did not. So nothing comes out. Only my x comes out. Here I am thinking that I've got 4 2's. I was wrong. So only my x comes out. Now I have a negative here. So it's a 4th root, which means that it's even. So I end up with an imaginary number because this negative and a 4th root. And then whatever I couldn't circle, which I couldn't circle any of my 392. And I have x squared. I'm sorry that I did not do this ahead of time and make sure that I had it correct for you, but you get to see the mistakes I make. We learn more from mistakes, right? Okay, and then the last one we have to do is the fifth root of negative 224 x to the 10. So we're going to break down 224. It's even, so I know that I can divide by 2. So I get 2 and 112, 2 and 56. 56 is still even, so 2 and 28, still even, 2, 14, 2 and 7. And then I have x to the 10. So all I've done so far is break down what's inside my root, what's inside my radical. Then the next thing I'm going to do, I have 5, which means I need 5 of anything to break it out of jail. So anything circled gets to come out. So I have 2x squared because I have 2 groups of those. And then the last thing I have to do before I start writing my radicals is I have to see this is a negative number and this is an odd root. Odd roots give me a negative answer. And then I write whatever I did not circle inside my root. I did not circle a 7. That's it. So that's my answer. The big change, or the big thing that you need to look at now, is if I have a negative number, an odd root means that I'm going to have a negative answer, and an even root means that I'm going to end up with an imaginary number.